Assalamualaikum and very good morning to everyone. So today we're going to discuss this called new topic, chapter 6 on production, costs and revenue theory in your textbooks. It is sometimes called production and cost theory, theory of cost. So in our last discussion, we have discussed the chapter 4 on the market equilibrium. So simply that we jump from chapter 4 to chapter 6, uh, we have to skip chapter 5. You can read on your own, but chapter 5 will not be tested in your examination, neither nor in your uh, quizzes. So basically chapter 6 consists of two parts. uh, First is called the production, okay, and secondly is called theory of cost. So production involve cost, therefore these two topics are discussed in chapter 6. All right, so this is the lesson plan for the first part of this slide, which is production and cost theory. So our focus is on production theory only. So there are three things that will be discussed. First is short run production uh, versus the long run production. Then we have to look at, in short run production, we have law that we call law of diminishing return, okay. As for the long run production, we have law that we call return to scale, okay. So basically it depends on the time frame given to you. Is it short run or is it long run? If it is short run, then it is called law of diminishing return. If it is long run, it is called uh, return to scale. All right, so in law of diminishing return, we will try to see uh, this concept by showing the stage of production, where here you have to identify the most efficient stage of production for the industry. So basically chapter 6 is all about industry or firm. So we want to see how firm try to minimize the cost given they have to maximize the production. All right, now, so the short run production is the first part where before we begin, it's good to know what we call the factors of production. In our class, factors of production is also known as input, or also known as what we call the uh, other than factor of production is also known as input, or sometimes called uh, resources. All right, so factors of production represented by four factor input called land, labor, capital, and entrepreneur. Conventionally, there are only two of them called labor and capital. Okay, uh, but in our discussion, we divide this into four: land, labor, capital, and entrepreneurship. Now, why do we need land, labor, for example, or what we call the factors of production? Because if we want to produce good, we need the labor, land, capital, entrepreneur. So basically, before we can produce good that we call output, we need the input. Okay, that input is called factors of production. Okay, so as you can see here, input divided into two. First is fixed input, second is a variable input, right? So in the short run, input divided into two. First is fixed input, second is variable input. What does it mean by fixed input? uh, that input remain the same, the quantity remain the same, uh, no matter what happened to the quantity of output. Okay, as for the variable input, as the output increase, the input also increase. Okay, so the best way to show you is to understand the production function, and the relation between input and output. So what is production function? It is a function that shows relationship between the input. What are the other name for input just now? Factors of production. Okay, so you need the input, okay, in order to produce output. All right, so output is example goods and services. Let's say we're talking about car. Car, is it input or output? Car is output. So what it takes to produce a car? You need the input. Example of input, you need labor, capital. So basically, uh, this relationship between input and output can be shown using the production function. Okay. So generally, the production function can be written as this. What is it? Okay, output. Okay, here, for example, car is a function of input. F represent is a function of input. Okay, so if you want to produce a car, okay, you need the labor, capital, land, and so forth. So meaning that car is subject to the input. Okay, the more input that you have, the more output that we can produce, right? However, in the short run, okay, as you can see just now, Q is output, input are labor, capital, and entrepreneur. So sometimes labor is simply represented by L, capital is represented by K. Now, uh, as we know that in the past, the the economy is divided into two. This is what you learn in the micro chapter 2, right? Where the time is divided into two. First is short run, second is long run. Short run means uh, it can be a day, it can be a week, but in economics, how we define the short run? It is very simple. At this period whereby there is a combination of at least one fixed input with one or more than one variable input, meaning that you have just now capital, labor, land, and entrepreneur. Okay, like this. So either one of these should be fixed. In our case just now, here I put the head here to represent that land is fixed. How about labor, capital, entrepreneur? They're all variable. But is it short run production function or long run production function? It is a short run. Why? Because as you can see here, one of the input is fixed. So in short run, at least one of the input is fixed. Okay, you have fixed input. How about the rest? It can be variable. So in the long run, there is no fixed input, meaning all inputs are variable. Okay, so in this case, you can see land, labor, capital, entrepreneur. There is no head in each of this, meaning that you can easily increase the quantity here, okay, the quantity of the output simply by changing the land, labor, capital, and entrepreneur. So that's how you define the short run and long run. Now, so next, I want to show you the law of production in short run and the long run. In short run, we have what we call law of production, namely law of diminishing marginal return. Therefore, I put that one S/R, meaning short run. Secondly, we have law of return to scale, or in bracket I said L stroke R, okay, bracket /R, meaning that it is a long run. Okay, so what is the meaning of law of diminishing return in short run? It simply means that as one input, mostly variable input, is added to land, in our example land is fixed input, okay, the marginal product will fall or total product increase at decreasing rate. Okay, so that's what we call diminishing marginal return. What does it mean by that? As we add one variable input on one fixed input, okay, to another fixed input, the total of output that you can produce, which is the Q just now, will increase, but it increase with decreasing rate, meaning that it increase, but the increase in there is getting slower and slower. So that's what we call law of diminishing marginal return. Now this can be shown in these uh, tables, all right? So in this table, what are information that available to you? Number one, land here is given. Number two, labor is given. Alright, so you have land, labor, and of course, one, the TP, AP, and MP, which is, what is TP? TP is total product, AP is average product, MP is marginal product. Either one will be given. Okay, either one would be given. Okay, for example, let's say land, labor, TP are available, therefore AP and MP are empty. Alright, okay, or maybe you have land, labor, okay, you have AP, okay, the TP and MP are empty, so depend on, but mostly the first two here are given. Okay, so let's say in our example, land, labor, TP are given. Okay, so you can see here that land is fixed input. Why? Okay, because the TP, the Q just now, the TP here, as it increase, the land remain the same, therefore it is a fixed input. How about labor? As the Q increase, the TP increase, the labor also increase, therefore labor is variable input. Variable means it keep changing. Okay, it does not fix. Now your task is actually to calculate the AP and MP. Which AP or MP that you need to calculate and MP that you need to calculate? Obviously, you need to calculate the APL and MPL instead of APK and MPK. So you need to find the APL and MPL. Why? Because here we are talking about the changing input labor. So that's why APL represent average product of labor, MPL represent marginal product of labor. Now this AP and MP can be calculated using this formula. Okay, okay, so which is average product and marginal product. Let's say you have average product here or marginal product here, you can calculate the TP. Okay, let's say information about AP is available, therefore you can calculate the TP. Okay, how do you calculate TP? The Q just now, Q equal to APL, okay, times Q, meaning that quantity of labor times average product of labor here. Okay, meaning that for every labor that we have here, we must calculate the product they produced by each of this labor. So that's why we call TP equal to APL times L times Q or times L sometimes. Okay. So example here, amount of labor is 4. Okay, here 4. Amount of APL, each of this labor can produce 4 unit. Okay, each of our labor is can produce. So it is 4 times 4 equal to 16. Okay, so the total output produced by all 4 labor, given that each labor can produce 4, is 16. So that's what we call TP. Okay, now as you have the MP, as you have the TP here, you can start calculate the AP and MP. Okay, given that you remember this formula. So what is the formula of AP? AP says that average product of labor equal to TP divided by Q. So in the table just now, you already have this information TP. Okay, okay, so where is the TP? Here is the TP. So you have this. So actually, what do you do? How to calculate the AP just now? You said you take the TP divided by L. For example, 3 divided by 1 equal to 3. 7 divided by 2 equal to 3.5. So that's how you calculate the AP. How about the marginal product? Marginal product is simply measure the change in output as a result of additional change 1 unit in labor or variable input. Okay, in our case, labor is variable input. So the formula is MPL equal to change in TP, total product, the Q just now, divided by change in QL. Okay, or change in L. So what happened here? You need to specify the change in TP. What is the change in TP? Change in TP is TP new, okay, minus TP old. Okay, the new value minus the old value. How about the Q here? The QL means the amount of labor or new minus amount of labor old. Okay, so I'll give you example how to calculate given that you remember this formula. What I said earlier, TP1 minus TP0, Q1 minus Q0. Okay, so here. So for example, let's say we calculate this 4. How do we get 4? Okay, okay, why we don't start from here? Because in here you don't have information before labor equal to 1. Prior to labor equal to 1, you don't have information. So that's why we start from here. So 4, how do you calculate 4? I said earlier just now, I said to you just now that 7 minus 3. Okay, 7 minus 3 equal to 4. How about the labor here? 2 minus 1. Okay, so just now information that you have here, 4 divided by the change here, the difference here, 4 divided by 1 equal to 4. Can you do it again for this one? For example, 33 minus 7, okay, divided by, this is change in TP, divided by change in Q or QL or labor. So here 3 minus 2, which is also 1, therefore it's equivalent to 26. So as you do for the rest, you will get the MP, given that you already have the TP and also labor. So as we identify this, we will notice that here the MP is increasing. That's why we call it increasing marginal return, meaning that as we add more labor, the TP also increase. How about this one? Okay, we call it decreasing, decreasing marginal, decreasing or diminishing marginal return. Okay, why? Because the MP start to decline from 19, 14, 10 and 4 until 0. So that's why we call diminishing marginal return. What does it mean by that? As we add more labor here, you add more labor, the TP increase but at the decreasing rate. How do you know that? Because here it increase the TP, but the change here becomes smaller and smaller, decreasing. Okay, and the last part is called negative marginal return, where the MP start become negative. Okay, now so that's how we have that, the calculation. Now if you translate that calculation here, the table here, into the graph, this will be the form of the graph. Okay, so there are at least 3 graphs. The first is the TP, total product. Secondly is the MP, marginal product of labor. Remember, because labor is the variable input, it is not capital. And then you have the AP here, the AP here. Okay, that's the AP, average product of labor. Now from there, you must, number one, you must understand that the purpose of drawing this curve is actually to identify in stage 1, stage 2 and stage 3, we need to identify which stage is the most efficient. Okay, so because if we be able to identify the most efficient stage, we can start produce our goods. Otherwise it's going to be waste or it's going to be under production. So how do we draw this curve is very simple. That the idea is very simple. You need to draw the TP first on the top of all curve. So TP just now, so TP from 0, okay, you draw it positively, then it reach the maximum. What does it mean by TP maximum? After it reached maximum, the TP start to decline. Okay, you must make sure that the TP after it reach the maximum, it start to decline. So that's how you draw the TP, up maximum and start to decline. Now associated with maximum TP is here. Okay, you need to draw the the MP. Do you notice that when TP at maximum here, you draw straight line, the MP equal to 0. This can be proven in your graph. Now, so meaning that you have to draw the MP from 0, has the maximum, then it start to decline. But make sure when the MP equal to 0, how do you know it is 0? Because if you bring here, it's equal to 0. At the same time, the TP at maximum, so they must be parallel in terms of the position of TP maximum and MP equal to 0. Right after that, the MP has to be negative or decline in negative rate. Okay. Now that's the number 2. TP maximum, MP must equal to 0. So I said earlier, first is TP must have maximum, then it start to decline. Number 2, when TP at maximum, MP must equal to 0. The third curve is the lowest one here. Okay, So this called average product capital. Now this curve, it also has the maximum, then start to rise maximum. Once it reach the maximum, okay, it start to decline. But the key here is this: the 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 meeting point between AP and MP here is where the AP at maximum, meaning that the AP must, I mean the MP must cross the TP when the MP must cross the AP when AP at maximum, meaning that they cannot cross here. They cannot cross here because this is not maximum. This is lower part. Neither nor here. So this is the highest part. So meaning that the MP must cross the highest part of the AP. So from there, you can divide this into three sections. Okay, here it is called stage 3. This is stage 2, and this is stage 1. Now the details about stage 1, stage 2, and stage 3 are given in the next slide. Now, so what is the most important about this stage is you need to understand not only where it begins and where it ends. You need to understand what happened in here. Okay, so in stage 1, what happened is this. It is called increasing return. In here, what happened is number of what we call number of the fixed input versus the number of variable input. Okay, in here number of uh, fixed input is greater than number of variable input. For example, number of capital is greater than number of labor, therefore it is a waste. Alright, because we have capital such as land, but the workers are smaller, therefore we don't reach the optimum. So basically firm will not operate in here. About in stage 2, in stage 2 the amount of capital and labor, or fixed input versus variable input versus fixed input, the ratio are equal, meaning that 1 to 1, one fixed input, one variable input. Therefore this is the best, okay, for the firm to operate. Okay, the rational producer will produce at this stage of production because TP already reached the maximum. That's number one. And at the same time, as I said earlier, the combination of capital labor at the maximum, which is 1 to 1. All right, so there's no waste. How about the stage 3? Stage 3, okay, the rational producer should not produce at this point because at this point, we will notice that amount of capital is smaller than amount of labor, meaning that there are too many labor in that land, or there are too many labor that using the machine. Land and machine are the example of fixed input, right? So the labor is a variable input. So this will lead to overcrowding, meaning that there will be idle workers. Okay, too many workers, but they cannot run the machine because the machine are fixed right there. So therefore I can say most of the time they will operate in stage 2. Okay, that's the idea. Okay, now we go for the long run production function. As I said earlier, the production function, long run production function is divided into 3. Okay, but the idea is we have to look at the return to scale. What does it mean, return to scale? Because just now we said that there is no fixed input. All input variable, capital, labor, they all change. Okay, therefore we can increase the output by changing capital and labor, including land and entrepreneur. Okay, so there's no fixed input. Now in this case we call it return to scale because all input are variable. Okay, now what happened here is we have increasing return to scale if all factors production or input are increased given proportion. Okay, output will increase by a greater proportion, meaning that as you can see here now, the total output here is 20. Okay, the amount of capital needed to produce this 20 output, the 20Q, is 100 capital, 100 labor. Now let's say I double the output from 20, I double to 40. Sorry, I double. Sorry, let's say I double the input. Okay, from 100 to 200, and I also double the capital from 100 to 200. So double means that 100% increase. But in here, the output increased more than double, increased more than 100, because here the input increased by 100%, the capital increased by 100%, but the output increased more than 100%. For example, here From 20 it increased to 60. Okay, so it is more than 100. How do you know that? Because 60 minus 20, okay, divided by 20 times 100, so you will get the answer. It is more than 100, therefore it is called increasing. Okay, what does it mean by increasing return to skill? As I increase the capital and labor in proportion, meaning that equally 100 100, okay, the output, the IQ increase more than the proportion that you have in the capital and input in labor, sorry, the capital and labor here. Okay, next is the best is to show you the constant return to scale. What does it mean by constant return to scale? As we change all input uh, or increase in proportion, here the output will increase at the same proportion. For example, here, let's say we begin with this point here, 100 labor and 100 capital are needed to produce 20, let's say 20, let's say we say 20 cars. Okay, now let's say I double the capital, 100%. The labor increase also by 100%. So the new one will be 200 labor, 200 capital. And what happened here is the output also increased by the same proportion here, 100%, 100%. Output increased by same proportion to the input here, 100, 100. That's why it is called constant return to scale. Okay. And the last one is decreasing return to scale. Remember, these all are in long run. Okay, what happened here? Again, we begin with 100 capital, 100 labor, so we are able to produce 20 car. Now, let's say we double the capital. Double the capital from 100, increase by 100%. Now it become 200. And as for the labor, also become 200 because increased by 10%, 100%. But here, what happened to the output? The output IQ will increase, okay, less than 100%. Okay, for example, from 20 it increased to, let's say, 30. So you notice that from 20 to 30 it is less than 100%. How do you know that? Very simple. 30 minus 20 divided by 20 times 100, you will notice the increment here is only 50% in output. However, in the input here, it increased more than 100%. Therefore, it is called decreasing. So in economy, most of the time we want to have increasing return to scale in the long run. But of course, in all, there will be a possibility that we have decreasing and constant return to scale. So I think that's it for today. Thank you for your attention.